Hey, what's up, guys? Jung here again. Today, let's take a look at another LeetCode problem here. Number 568, maximum vacation days. So the description of this problem is kind of long, but don't worry, don't be afraid. It's still a it's still like a very basic DP problem here. Let's take a look. So there's an employee of LeetCode, and this employee wants to take a vacation. And there are two parameters in terms of this vacation. Basically, there are like total N cities that this employee can stay, and there are like case in case weeks in total. And so you're given like a flight here, right? So flights is the N by N. Basically, it tells you if there's any flights. Basically, if there's any connection between those cities, right? So if if flight ij is 1, it means that there is a flight from city I to city j, which means there is an edge, right, from city I to city j. And here you have another like 2D array here with it's n by k. N is the number of cities, and the column is on each week. If you stay, how many vacation days how many days you can stay on that city, and it just asks you the maximum vacation days this employee can take, right? So it's a very like classic, what can you call it, a graph plus DP problem, right? Basically, in this case, the basic idea is that we try all the possible ways, right? For example, if we are at the city, the deep city, basically this problem like it's a 2D DP problem. Basically, the first one is the city, second one is the current week, right? So for me, I'm for me, it's the top down in this case is more intuitive because by the definition of this problem, it's we're moving from one city to another, right? And so it's easier for me to calculate the possible moves from current one to the next one since we have this flights here. That's why I decide to use a top down. Otherwise, if we want to use like a bottom up, which means you need to go backwards, you have to check, okay, with the current city, how many cities it can guess to the current city, right? That's also another way. Basically, with that solutions, you have to do a reverse check of the flights matrix here, I and j. Basically, you're doing like the current is j, and you will see how many i's have the ones to the current city. That I mean that also works, right? But in my case, I'm just feeling like I'll try to do a, like in the normal way, which means I'll see with the current city how many cities we can get, how many ways we can do, right? Or how many cities we can go at the current city, right? In that way, we can just use this flights or the graph in the normal way, right? So let's say, for example, we have this graph, right? So basically, we have 0 and 1 and 2, right? So basically, this in this graph here, basically we have all the cities. We have we have flights between each city, right? So basically, for example, if we're at city 0, we are at city 0, right? So how many options do we have at city zeros? We have three options, right? The first option is always stay at the current city. And all the other possible options is we'll check how many cities we can go from the current city. For in this case is 0, and we see okay, we can either go to 1 or go to 2, right? Or stay at city 0. And if we are go to stay at 0 or go to 1 or go to 2, the next will be how many we can get from there, how many days we can stay from that state, right? And for the current one, we just need to get the values of the current vacation days, right? Plus the DP of the of whichever city we decide to stay here, right? It could be the 0, could be 1, could be 2. So basically, they're gonna be next city, right? Plus the weeks plus 1, right? Because since we have already decided to stay at any cities here, so the next one will be a weeks plus 1, okay? And basically, that's the DP of current city and the current week, right? Yeah. Okay, so let's try to code these things up. So since I'm going to so for me, I'm maintaining a graph here just to for us to improve our speed a little bit, so that we don't have to loop through all the cities from 0 to n, right? If we don't have this graph, we have to loop through every time we want to check which cities we need to go. We have to loop through all the cities, right? But here, I think I'm just doing a graph here because this problem for the flights, it's like a graph here. So I'm just defining a like default dictionary as a list, right? And then for I in so this is going to be n. The n is the city, right? City is the same as the dimension of the flights. So I'm going to use the flights here. Length of flights, okay? In range n for j in range n, right? Basically, if flights I j is 1, I just add an edge, right? From I to j, okay? Right, so that next time when I try to check, okay, from the current city, how many neighbors I can go, I can just quickly look through this graph here, right? Mm, and then will be the DP, right? Gonna be the city and the week, right? And in the end here, we simply return the DP, return DP from starting 0 of week 0 because it says we always initially you start from the city 0 here, okay? So yeah, and with this kind of recursive solutions, we always need memorization here. So basically, if city and week is in the memorization, right? So this is more like a template, right? I'm assuming you guys already know this. We simply return the values from the memorization dictionary here, and we're gonna have answer, right, with the system max minus max size here. And in the end, we have a we'll update this memorization dictionary here, and we just return the answer, right? So, so now let's implement how can we uh, uh, get the max value of the answer. Like I said, it depends on how many options we have currently we currently have, right? So like I said, the first option is always to stay at the current city, right? Which means we don't move at all. That's going to be the answer equals to max answer. So if we decide to stay at the current city and with the current week, we can get the vacation days, right? For this city for this week, right? So that's going to be the days and city and week, right? So that's the current one. And after doing this, right? So, and then we're gonna pass after this, I'm going to, the next one will be the city starting from the same city, right? Because we're staying at this city. So on the next week, we will also start as this city, okay, right? And the week is week plus one, right? Because we already stayed 1 week at this city. And so that's the staying at the same city, right? Now going to other cities for neighbor, right? That's how when we need to use our graph here in graph, so that we don't need to loop through everything from the flights. Otherwise, we have to check the flights uh, for all the cities, right? Mm, uh, yeah. So same thing here. So days. So that means we decide to stay at this neighbor city with the current week, right? Plus, since we're staying at that city, so the next week will also start from that city, right? And the week will also be weeks plus one. Okay. And since we're going to like keep moving the weeks forward, so there will be always a point that the weeks is over. It's has reached the end of our vacation, right? So for that, in that case, basically, if the week is greater than the weeks, do we have a weeks here? Oh, we don't have a weeks. Okay, so the weeks is the length of the days 0, right? That's the total weeks we have. So weeks minus 1, right? Since it's 0 based. Return 0. Basically, if the week is already greater than our vacation length, we simply return 0, which means this DP will just simply return a 0, right? Mm, yeah. So return. Yeah, I think that's pretty much it is for this problem. Let's try to run it. Okay, so this one passed. Let's try to submit it. Submit. Hmm? Hmm. Let's see. Did I do anything wrong here? Current city plus DP city week plus week plus one neighboring graph. Hmm. Yeah, I don't see any issues here. should be the should work. Uh, cities. Maybe there's some misused variables here. For example, the n here, weeks 0. Let me see. Oh, I think I know what's the problem here. So when we trying to get the neighbors for the current cities, we forgot to pass in the key to the to this graph. Okay, okay, let's try to submit it again. Yeah, cool. So this time it passed. All right. Yeah, just to recap, do a recap real quick. So so I think it's also a classic problem. Just like it's like I would say it's like a medium level DP problem, but um, what makes it hard is the it gives you a long description, right? And the flights and the days, right? So first you have to try to convert these long descriptions and the flights and days into a DP model, right? And basically from the with DP models, usually the DP model is basically we try out the at the current state, right? At the current state, uh, with DP, basically the problem is always asking you to do like either the minimum or the maximum value, right? So the DP idea is that at each state, the each state, basically you try all the possibilities, right? You basically you try all the scenarios, and then within among all the scenarios, you get either the minimum or the maximum value. So and the state, basically this days represents the states of this DP problem. And then how about the other scenarios? Then the scenarios is the flights, right? So as long as you can figure out this is a DP problem, and to get the states, you need to look at the days list to the array list here. And to get all the scenarios, you need to look for this flights to the array. As long as as long as you can figure out those two things, yeah, it shouldn't be a too hard a problem for you to solve this problem. Yeah, because for me, I'm using a top down because it's easier for me to deduce the solutions like from one city to another that's aligned with the flights, right, from city A to city B. If you want to do a bottom up, you need to look at this flights in the reverse way, like with the current cities, right? How many cities can get to the current city, right? So basically you have to search these flights in a different way. Hmm, cool. I think that's pretty much it is I want to talk about for this problem. Yeah, and yeah, thank you so much for watching the videos and stay tuned, guys. And I'll be seeing you guys soon. Bye bye.